Okay, good evening, everyone. So for those of you who frequently attend MAWDC monthly meetings, you'll recognize that one metropolitan area in particular provides speakers more than any other, Pittsburgh, Pennsylvania. That's because our sister club, the Western PA Mushroom Club, is based there, and they have a deep, deep talent pool of passionate amateur mycologists. In the past year alone, we've heard from John Plischke and Judy McEnroth about crust and polypores. We heard from Lamont Yarrow about slime molds. We heard from Fluff Berger about summer mushrooms. And tonight we're going to hear from a past president and longtime collaborator with MAWDC, Dr. Richard Jacobs, who came to this fascinating pastime in a familiar manner when he found and identified morel growing in his backyard. He was immediately hooked, and I think many of us can relate to that. Tonight, Richard will be telling us about bioaccumulation of heavy metals and fungi. So if you're a pot hunter, and if you're listening to me just now, you are, please pay close attention and join me in giving Richard a warm welcome. Good evening, Richard.
All right, thank you. It's a pleasure to talk again to the club on a different subject, and thank you for inviting me. So I'm going to share my screen. Okay. Which
it's got it. We see it.
Okay, hopefully you can see. Perfect.
Yep, everything's good.
And so this talk was actually I put together last year, and it was just at the start of COVID, and we didn't have the guest speaker anymore, so it was put together to fill that gap on one of the first Zoom meetings. And anyway, I think it's an interesting talk and a project that I've been slowly working on. Not much was done last year, but it's starting up again. So heavy metal contamination in edible mushrooms. And I know that there's been a lot of research on this topic by academic scientists for many years. And people like the FDA track metals in food and food products. So it's something that, you know, people are thinking about and have been thinking about for a long time. And within the fungi world, we know that some fungi species absorb and bioaccumulate metals in their fruiting bodies. And this is some of the ideas behind microremediation and you know, use of mushrooms to remove toxic products from soil or from different areas. And if you know anything about Pittsburgh, you'll know it's pretty much a steel city. That's the history of the city. And because of the steel and the mining and the metal smelting and everything that goes with a steel industry, there's a lot of heavy industrial sites in the city with potential for a lot of pollution. So putting the sort of two and two together, you know, mushrooms are known to absorb the metals, and Pittsburgh has a lot of metal industry. I thought it would be worth sort of starting a project out of this. And reading over on the web, I'd seen people analyzing and testing mushrooms, particularly morels, for arsenic. So arsenic pesticides were used on apple trees, and then the arsenic pesticides sort of dropped off the leaves into the ground around the apple tree. And when you go pick morels from old apple trees, you might find arsenic in them. I didn't see any positive reports of arsenic in morels, so that's good news. And we're starting to look at a few morels now. And you know, part of these mushroom clubs in general is to provide education to members. And I thought sort of this was very interesting to a lot of members who are interested in, you know, pot hunting mushrooms to eat. So here's a historical picture of just one part of Pittsburgh. This is the Homestead Works. And you have to imagine that there were 250 mills like this in the city. So all along the riverbanks, both sides of the rivers, we've got two rivers meeting, it goes into the Ohio River. So along the sort of three banks of the rivers, you've got mills all the way. Quite incredible to have seen back in the day. But all of these towers here, all of these chimneys are going to be putting out smoke and soot, which is going to drop into the local environment. So what are heavy metals? And are we talking about heavy metal bands? So we have the new wave of British heavy metal here, Iron Maiden and Judas Priest. So that is not what we're thinking of, although they are wearing quite a bit of metal, especially the Judas Priest picture in the bottom there. And so when people talk about heavy metals, we're talking about this sort of high density metals in the periodic table. And these include the sort of arsenic and lead and cadmium. Also some metals like zinc, nickel, selenium and silver and so on. These are all ones that naturally occur in the environment, as well as sort of produced as a sort of byproduct of mining and smelting. The correct term for them is not really heavy metals, but potentially toxic elements. And the reason is not all of them are that heavy. And also, not all of them are poisonous. So some of these metals, zinc, for example, this is an important trace element and micronutrient. But in higher amounts, it can be toxic. So this is the correct modern term. I've used heavy metals mostly throughout this presentation because that's what everyone is familiar with. And I mentioned that some of them are essential micronutrients, and if you have a deficiency of them, you'll have various diseases and syndromes that the doctor might diagnose and then prescribe vitamins or metal-containing pills or whatever to go pick up from the pharmacy. But what we're interested in is the effects of excess metals, and the most sort of common general effects are gastrointestinal and nervous system problems. And basically they're interacting with the body, with enzymes in the body, and also with DNA, binding to DNA. And this can shut down the basic cellular processes and cause sort of GI upset and other issues. A lot of the famous metals, stuff like lead, often comes in water from lead pipes. So these are linked to bone, heart, and behavioral disorders. Mercury, if you think of the Mad Hatter and using mercury for making and forming hats. This is Lewis Carroll, Alice in Wonderland. So this causes brain and kidney damage and loss of cognition, hence the madness. Arsenic, a carcinogen, and cadmium, which is similar to lead. It's in the same group. Sorry, it's not in the same group, it's alongside, but it has a similar effect to lead, and it causes heart disease, skin and kidney disorders. And the first question when thinking about these metals is, what is the safe limits? In this presentation, I use milligrams per kilogram of dried mass or wet mass, depending. In most cases, I've used dried mass. And you can also see them reported in parts per billion or parts per million. So 1 part per million is equivalent to 1 milligram a kilogram. And 1,000 parts per billion should be 1 milligram a kilogram. So the FDA does not establish any limits for metals in food, and except for water. And it does have a couple of guidelines though for arsenic in apple juice, particularly for the reasons I mentioned. Oops. And lead in hard candy. So some hard candy manufacturers were using lead molds to help release the hard candy easier, and some of the lead was sort of wearing away and getting stuck to the candy, and they discovered that this was a problem, and then they started testing candy for this. I believe it was particularly candy imported from Mexico. Of course, once people know that this is a problem, people change the molds. They use a different metal, and that problem has pretty much gone away. The other thing to think about is arsenic in rice. This is quite a common issue and becoming a more well-known issue. So as the FDA doesn't give any guidelines, what I've done is I've looked to the European Union and Asia to see what guidelines they have. So here's some of the common metals with guidelines. We have the European Union, who sort of set a benchmark. The Czech Republic, this is all milligrams per kilogram dry weight, and the Czech Republic, they have amounts in for forage mushrooms, and they have a big history and cultural importance of going out and foraging for mushrooms and eating them. And they also have a history of metal smelting. And so because they didn't want the general population to not be able to pick the mushrooms, they actually have higher limits than the European Union, particularly in lead. And I think that's just so that, mushrooms picked locally pass their safe limits. And China, again, the limits are a little more relaxed on some of these different metals. Lead is the same as the Czech Republic, and tin is a bit higher. So that's given us a baseline of what to look for. And the metals, in Pittsburgh, we're interested in metals that are sort of come from the environmental contamination, mining, foundries, and smelters. But they can be found in the environment naturally, particularly volcanic eruptions. And if you have coal burning plants or petroleum combustion, then these again might drop soot and distribute metals around the area around that power plant. Plants do bioaccumulate metals, but generally not to dangerous levels. And the exception is arsenic in rice, which I mentioned earlier. Most of you know about mercury in seafood, and this is principally food chain accumulation. So mercury gets into the waterways, particularly when it was used in mining and purification of precious metals. And a lot of the mining waste then gets into the water. People used to use mercury beds to help capture the silver and gold. And some of the mercury would escape from these purification plants. And you can see some of these potentially toxic elements in refined plant products. So just like food chain accumulation, if you refine a plant product enough, you can also refine any toxic elements that might be there with it. And so the FDA does track metals, although it doesn't have any limits, it does track metals in over 700 food types for contamination. So there's been a lot of research in bioaccumulation of metals in mushrooms, and over 40 different metals have been analyzed, but we're only going to look at the known problem metals. So this is arsenic, cadmium, chromium, lead, tin, and mercury. Each of the different metals, some of them the tests can be combined on one particular instrument. Sometimes you need to use different instruments for different metals, and to sort of keep the cost as a sensible level, we've picked the ones which mushrooms are most known to accumulate and are most likely to be in our environment. So there's a couple of interesting species of mushrooms. So some mushroom species are hyperaccumulators, and they bioaccumulate metals many hundreds of times over the substrate or soil. And so when we started this project, we don't just collect the mushroom, we collect a soil sample as well, and we analyze both of them. Most common edible species have been tested somewhere in the world. We're really interested in the species that are around Pittsburgh, and pretty much everything that grows around Pittsburgh that's going to be edible is going to be found in Washington, D.C. as well. And mycorrhizal species tend to accumulate more metals than sapphirites, and members of the bolete and the amanita families are both known to accumulate more than some other species. And there's one particular European amanita, Amanita strobiiformis, that hyperaccumulates silver. I don't know if you can pick enough mushrooms and then, burn them to the ash and actually get silver from them, but this is probably a good indicator that silver is in the area if you find these mushrooms. And that may actually not be true at that point. So I don't know if they require silver to grow or they just bioaccumulate it. So it's probably just bioaccumulating it. So in my trial study, we wanted to see, could we just do this as a project? Can we accurately measure the metals in the fruiting bodies? Can we find a place to measure them that has enough sensitivity for the soil and for the mushrooms? And are there any metals of concern? So in the initial study, we looked at 2 species, smooth chanterelles. They're abundant and local, and the bicolor bolete, just as a bolete species to start with. And again, fairly abundant, found in all of the local parks in the area. And we collected from 2 locations, Deer Lakes Park and Heartwood Acres. These are both in Allegheny County, and they're both close to Pittsburgh. Many of the parks have been given to the county, and some of them have been used for other purposes in the past, including industrial sites. Not Heartwood Acres, but Deer Lake Parks definitely has been used in the past. And as I mentioned, we collected soil samples at the same time. So here's a couple of the pictures. Lamont Ural, who you heard giving a presentation to your club not long ago, and myself, we collected samples from the 2 sites. And we just took a soil sample from the top of the soil. So we didn't dig down deep, only an inch or 2, and then collected a soil sample, put it into a paper bag. We put the mushroom into a separate bag, and then we dried both in a dehumidifier, dehydrator, and really until it was completely crisp for the mushroom and the soil was super dry and crumbly. And we collaborated with a local testing branch. This is Eurofin's Test America, the Pittsburgh branch. This company and similar companies, they have all the required equipment, which they have to obey certain regulations, particularly with the sort of mining and the fracking industry. So they take a lot of soil samples and other samples from these industries. And they also do things like lead samples from water. They do soil samples from different areas. But everything is calibrated and verified. So this is, properly maintained equipment that they use. For the mercury, it's cold vapor atomic absorption spectroscopy. And there's a couple of different methods of measuring mercury. And this is the recommended one that we can see from various publications. And for the other metals, we used inductively coupled plasma mass spectrometry. And the soil or the mushroom sample is then atomized into gas, and then the metals are measured basically by weight. So this is the results. what we've got is each sample is a pair. We've got the mushroom starting from the left, Chanterelle at Deer Lakes. We've got the mushroom and arsenic. We can see there's no appreciable amount, but in the soil at the Deer Lakes where I picked the Chanterelles, there's quite a high level of arsenic. But basically you can see as you go along the arsenic, the mushrooms contain very little arsenic. The orange bar is the recommended European limit, and the soil all contains more than the mushrooms. So none of these mushrooms bioaccumulate arsenic. In cadmium, we can see again the soil and the chanterelles, which are the first two here, contain very little or no cadmium. The bolete, the bicolor bolete, however, from Deer Lakes contains quite a lot of cadmium. So this is 20 milligrams or just over 22 milligrams per kilogram of dried weight. And this is bioaccumulated by a large amount over the soil sample. And the same species has also accumulated cadmium at the other park, Heartwood Acres. Again, this is pretty much at the limit, but it's also, it's accumulated quite a long way over the background soil sample. So this is certainly a worry. We looked at chromium and lead, and we can see mushroom soil as we go through. So the soil samples for chromium are all high, and the lead samples for the soil are all high. But in most cases, the measurements for the amounts in the mushrooms are low. There's a little bit of chromium in the bicolor boletes and a little bit of lead in the bicolor boletes, but not bioaccumulated over and above the soil and below the safe limits. Tin, we see no accumulation in either the mushrooms, and the soil levels are low as well. So we have no issues there. And then we have mercury, and all of the mushrooms have bioaccumulation of mercury. This is up around 2 to about 3.2 milligrams a kilogram in chanterelles, and pretty much 2.5 milligrams a kilogram in boletes. And this was quite a surprise to see these higher levels of mercury. So the question is, how can we compare these mercury levels to something that we understand? And one way of looking at this is at fish. And the USDA reports the following levels for different fish. This is taken from a study that measured approximately 50 samples or 50 specimens for many different species of commonly caught fish around America. And we can see levels of mercury at 1.84 milligrams in big eye tuna and swordfish and tarfish, both in the 3 milligram kilogram range, and shark is higher at 4.5 milligrams a kilogram. And all of these fish are larger fish, and they're generally at the top or closer to the top of the food chain. And so this is where we're seeing that sort of mercury accumulate from the smaller fish into these larger fish that eat them. And fatty fish in general accumulate more mercury than non-fatty fish. So fish like mackerel can have higher amounts. So the FDA recommends only 1 7-ounce helping per week of large fish, such as shark and swordfish. So this probably means that we need to be looking at sort of 1 7-ounce helping of mushrooms per week. So there is a question about the mercury, which I'll get into in a second. But for reference, mushrooms collected from smelter sites in Slovenia had a lot higher levels of mercury, up to 200 milligrams per kilogram. So you definitely wouldn't want to eat mushrooms from those sites. And the levels that we see reported around Pittsburgh are similar to levels reported in other areas where there's smelters and ironworks. So we don't have unusually high levels here, but they're probably higher than sites that don't have metal smelters and metal foundries in the area. So actually, I'm going to talk about the second half first with the Mercury. So when looking at the Mercury, one question on the analysis side was the dried mushroom specimens were very light. And when they're taking the sample, they had to crush up quite a lot of mushroom to put into the instrument. So, physically it looked like a lot. And the concern was maybe there is some background contamination from the lab, and it's not all from the mushroom. So one experiment that we haven't done yet that we need to do is compare the results to a store-bought mushroom. And the idea is that a store-bought mushroom grown on wood substrate should have very low levels of mercury, and we can see how that compares. Now with the bioaccumulation of cadmium, Deer Lakes was 4 times higher than the EU limit, and the Heartwood Acres specimen was right on the limit. So for Heartwood Acres, about 21 times constant bioaccumulated over soil and 170-fold or times over soil for the Deer Lake specimen. So this is pretty high bioaccumulation. We need to find out whether this is species specific or site specific. So we need to collect the same species from more different sites, and we need to collect different bolete species from the same sites. And that's what we're going to be doing this year, is expanding our samples. And I think we need at least 5 or 6 samples of each species before we can really say anything conclusive. 2 samples is just not a statistical analysis, but it certainly tells us that it's something that we need to investigate further. So the club has put forward more funding for samples. We're also going to be looking at a number of sites. There's a site that is opposite a coal power plant. So this is one site that we want to analyze. And there's other sites which are known mining areas. Again, we want to analyze those and just see if these have even higher levels or if they're different to what we've seen from Deer Lakes and Heartwood Acres. Again, we want to look at more edible species and see which other ones might be bioaccumulating, and see if there's any particular sites that bioaccumulate different metals. And again, not just looking at mycorrhizal mushrooms, but looking at a couple of different mushrooms, morels, and things like chicken of the woods and hen of the woods, and see how they're bioaccumulating and if they are or not. Okay, so I should acknowledge Debbie Lowe at Eurofins. This is one of my neighbors, and she very kindly took those initial samples and analyzed them at no cost. And that was sort of, chatting to her one evening was what started the project. And this is something that, is pretty easy to do. It's very easy to, hand samples over to these analysis agencies. Data analysis is very easy. They just give you the amount in milligrams per kilogram. So there's no difficulty on the analysis. And there's a lot of publications available from all around the world, which are free. So you can read up quite a lot on this at no cost. There's one book that I used, and this is this mineral composition and radioactivity of edible mushrooms. This is an expensive book, over $100, and it's really a academic book, academic publication, but it goes into a lot of detail in bioaccumulation of all the different metals, and references a lot of papers and so on. So it's like a book come review. So I found this as a good starting point. So that's pretty much it for this topic, but I'd be interested in any questions you might have.
So we had I think a couple in the chat, but I'd like to keep them extremely brief because we have quite a bit to go yet tonight.
Yeah,
And one
go ahead.
person asked if you could return to a slide. So I will tell everybody, this is on YouTube. Anybody who wants to go back and look at it can do that. So Elizabeth, we use the chat room. Do you have like one question or two questions we could cover quickly?
Yeah, so that was Annie that wanted to see the Mercury, and then Ben also had a question about Mercury, which is that Mercury, pure Mercury is volatile. So is the Mercury that's getting bioaccumulated in some sort of compound that's making it more stable in the mushrooms?
So I think it's a methyl mercury compound that is generally absorbed from the soil rather than mercury ore. So it's normally mercury that's reacted with other chemicals in the environment and formed a metal methyl organic chemical compound, and that's what will be accumulated.
And Marisol is asking, I'm not sure if she's asking if you want people to forward collected mushrooms to you, or is that how you're doing it in Pittsburgh? Are you having members of the club just go out and send stuff in, or?
Yeah, so within Pittsburgh, we're going to be getting our members to collect specimens and soil from different parks where they go to, and then we're going to be taking a selection of those and analyzing them.
Cool. And just for folks, if you want to check out in the chat, Tom McCoy also posted a link to an article about researchers that are using mushrooms to clean up electronic waste. So sort of taking advantage of the bioaccumulation that mushrooms do. So.
Yep.
Okay, thank you very much, Richard. That was a very excellent presentation. For one of the first ones I've seen where we've actually done real science in a mushroom club. I'm impressed.